Hey, welcome back. Today we're going to talk about API pagination in system design interviews. We'll cover why pagination is needed, the most common approaches, and what happens on both the client and the backend sides. I'll focus on the practical questions that candidates often get asked in real interviews. Alright, what is pagination and why do we need it? Let's take a look at a simple example. Here we have a client app that talks to a backend API, and the backend reads data from the database. Let's say the database has 10,000 elements. The naive approach would be to return all 10,000 elements at once, but this creates a few problems. First, obviously, it would create a high load on the database. Also, we'll have a really big payload to send to the client, and that would slow down the API response, and that leads to poor user experience on the client. So, how do we fix this? Instead of returning all elements at once, we can return data to client in pages or groups of elements. For example, we can return 50 elements at a time, and this works much better because most users don't need to see all 10,000 elements at the same time. Take Google search as an example. How often do you go to the second page of Google search results? Maybe 10% of the time, or even less. So, for this kind of scenario, pagination works perfectly. We retrieve only a small part of the data first, and then load more only when the user actually needs it. But of course, there is also a trade-off here. If we reduce the page size too much, we increase the number of requests to the server. So, choosing the right page size is important, and this decision depends on your product and the user experience. So, let's now talk about the types of pagination. We're going to focus on two main ones: offset-based pagination and cursor-based. Offset-based pagination can be implemented in two common ways. One option is to use limit and offset. Another option is to use a page parameter, usually together with a page size. But technically, page-based pagination is usually just another way to express same offset-based pagination. On the backend, we can simply convert the page number into an offset. We'll talk about how each approach works, what the trade-offs are, and when you should use one over the other. Let's start with offset-based pagination. Take a look at the example request here. Get posts with two URL parameters, limit 20 and offset 40. The response from the backend would contain the data, for example, the 20 posts that we requested, and separately pagination metadata. In the metadata, we can include useful information such as the total count of matching elements, the current limit, and the current offset. So, what is limit here? It's our page size, meaning how many elements we request at a time. What is offset? It's the position from where we want to start requesting these 20 elements. So in this example, the offset can be 0, 20, 40, 60, and so on. So this request means get me 20 posts starting after the 40th post. Now let's take a look at another example which is very similar, but this time it's page-based pagination. Here our request is get posts with URL parameters page 3 and page size 20. We are requesting the same 20 posts, but using a slightly different approach. We're using page numbers instead of providing an offset directly. Here, the first page would return elements 1 to 20, the second page would return elements 21 to 40, and the third page would return elements 41 to 60. And as we discussed previously, on the backend, this page number can be converted into an offset. Now, let's discuss what happens on the backend. Basically, in our API, we want to process the request and then retrieve data from the database. Here's an SQL query to get 20 posts with an offset of 40. Select all from posts, order by ID ascending, limit 20 and offset 40. Here, limit 20 means how many elements we want to return per page, and offset 40 means how many rows we want to skip. So this query would start from the 41st row. You can see that the SQL query uses the same naming as our paginated API request, limit and offset, and that's intentional. Alright, that's our first approach to implementing pagination, offset-based pagination. The biggest downside here of this approach is that it's row number based. It's just a number that represents how far we are from the start of the dataset. The problem here if the data changes while you're paginating, you can get gaps or repeating values, and that's a serious problem for some apps. With that in mind, let's now discuss the pros and cons of offset-based pagination. So first of all, the pros. This approach is simple and easy to implement. Second, we have random page access, which means that we can specify a certain page or offset and immediately load data from there. So it works well with stable, fixed-sized datasets because of the problem we discussed before. If the dataset is not stable, it changes while we're paginating, we can get gaps or repeating elements. Okay, now let's discuss the cons. The first one is that performance suffers with large datasets. This happens because our SQL query with limit and offset becomes slower when we have a lot of elements in the database, especially with a large offset. The database still has to skip many rows before returning the next page. And the second one is that results can become inconsistent if data changes frequently. Now, let's take a look at cursor-based pagination. The main idea is to use a cursor or a pointer to the last element we've seen. Instead of saying skip the first 40 elements, we say give me the next 20 elements after this specific position. Here's an example request. Get posts with limit 20 and cursor ABC123. The response contains the same 20 posts plus pagination metadata that usually contains the next cursor, the previous cursor, and the current limit. A cursor can be based on different fields, what we can use here. For example, we can use an ID, a timestamp, or some compound fields. But it's important to remember that we can't just use anything as a cursor. A good cursor field should be ordered, stable, indexed, and ideally unique. If the field is not unique, we usually combine it with something like a unique tiebreaker, like ID. For example, if we use our created at field as a cursor, multiple posts can have the same timestamp. So instead of using a created at, we can use a compound cursor, created at, plus ID. Another important detail here is that we can expose our cursor to the client in two different ways. As a raw value, for example, a post ID, or as an opaque cursor. Opaque just means that the client shouldn't know or care what's inside the cursor. It simply receives the cursor from the backend and sends it back with the next request. Then on the backend we can decode the cursor and turn it back into values that we can use for the database query. Now let's take a look at what happens on the backend. With our cursor-based pagination, our SQL query will look like this. Select all from posts where ID is greater than number, order by ID ascending, limit 20. You can see that we're using a specific ID of a record instead of relying on an offset number. This is the main performance benefit of cursor-based pagination. In real API, the client usually don't send 129834 directly. Instead, as I discussed earlier, the backend returns an opaque cursor, for example, next cursor, and internally that cursor can contain the last seen post ID, sort direction, and page size, maybe some filters. So when the client requests the next page, the backend decodes the cursor, extracts the last seen ID, and uses it in the next SQL query. In the simplest implementation, we don't need to store the cursor anywhere on the backend. And this cursor can be just a base 64 encoded JSON object. Interestingly, sometimes we may store cursors on the backend, for example in Redis, if we want them to expire quickly or, for example, be revocable. But for many cursor-based pagination APIs, a stateless encoded cursor is enough. Alright, let's discuss the pros and cons of cursor-based pagination. So the first advantage is that it's efficient with large datasets. Next, it handles dynamic data much better because we use a cursor that points to a specific position in the dataset. And we can move forward and backward throughout the dataset as long as the API provides both next and previous cursors. Now, the cons. It's more complex to implement on the backend. We need stable sorting, cursor encoding and decoding, and another con is that it doesn't allow jumping to any page or random offset. Okay, to wrap up pagination, let's quickly compare the two approaches. Offset-based pagination works well for small or stable datasets. It's simple and lets you jump directly to any page or some random offset. Cursor-based pagination, on the other hand, works best when you're dealing with feeds that update frequently, like social media feeds, comments, messages, or notifications. It's more efficient for large datasets, and it avoids skipping or duplicating items and handles dynamic data much better than offset-based pagination. So in a system design interview, if you're designing something like an infinite scrolling feed, cursor-based pagination is usually the stronger choice. Alright, thanks for watching and see you in the next one.